simulator. I have decided that I want to use the 332-inch thickness for balsa wood because to me it seems a little bit more consistent. To do that, I need to make sure that my AERY simulator is not going to exceed the dimensions of my material. Right now, the fuselage can extend a good bit, and I'm not sure that this matches the materials I have. To get those materials set, we're going to click on File and Edit Configuration. The configuration name certainly can be adjusted, but our main focus is to include the dimensions of our material. The max wingspan in centimeters was the equivalent of 36 inches or 91.44 centimeters. The max wing width is the equivalent of 3 inches, which for us was 7.62 centimeters. And then the wing thickness, that of course varies if you are using 1/8 or 332. For the 332, it looks like that thickness is 0.24 centimeters or 24 millimeters. Next, or 2.4 millimeters actually. Next, the wing density. I noticed that this number stayed exactly the same. Well, if I click on calculate wing density, the existing mass will be used to calculate the wing density. Click on calculate wing density and it will say enter the mass of that piece of balsa wood. For the 332, my groups measured at about 35 grams. As soon as I input that number, it is calculating the wing density for me. This balsa wood is indeed relatively dense, which is why our number increased. If you choose to use the 1/8 inch wood, your density, you should expect, will be a smaller number. Next, the fuselage. The maximum fuselage length is the dimensions of our basswood. Hopefully the group I am copying from has those dimensions measured correctly. The max fuselage length is 61.175. The fuselage width, or the top part of the fuselage, the narrower value, has dimensions of 0.675 centimeters, and then the height is 1.15 centimeters. Again, we want to calculate the density for the fuselage, and to do that we need to put in our average mass. This group said that on average each piece of fuselage is going to weigh 13.25 grams. The density here, instead of density, it is showing mass divided by length only and not necessarily density. Please keep that in mind. Don't be stressing out over the number, which is not really matching. Okay, next part, maximum nose mass. You are not going to, or you should not, count on 30 grams of nose mass. I will give you no more than 15 grams. I really want to say 10, but let's say 15. Your airfoil coefficient of lift, if you are going to sand down your wings or stabilizers, you can certainly adjust your coefficient of lift. Otherwise, leave it as it is. Leave the air density as it is. It should be the air density on a normal day. 1.22 makes sense. Go ahead and click OK. I noticed that my options here reset because my fuselage can no longer exceed the length of 61.18. One more thing extremely important to check is that in our preferences, we are only using one piece of wood. Now, if I change how large the stabilizer is, it will also change the possible length for the fuselage. All that will be taken into consideration within the software. Once you have your configuration edited, make sure that you save this configuration somewhere. So we're going to click on Save Configuration. We should place this configuration somewhere that we can access it. In case you do not finish getting a flyable glider today, you're able to access it on a different day. So either use your gallery or your My Documents folder. Make sure that you are saving your file somewhere. I will save mine directly on OneDrive so I can easily find it. And in terms of the configuration, we can give this configuration a name for our materials, or I can say Gallo Glider Materials for 2025. Our next step will be to go ahead and get a glider design that flies. And once we have that design flying, we would want to save the design before we attempt to print that.